When we think of chemical engineering, we tend to think of it as a single term describing an engineering degree or an engineering career. And in our everyday lives, we may use it in a very general way. For example, anything that you see remotely related to production or industry or pharma or oil, we may label it as under chemical engineering. But in reality, chemical engineering is actually a very broad term. It is in fact a collection of many sub-disciplines which only when put together and used properly gives you the magic that you see around you. So therefore, once you start studying a chemical engineering degree at university, you will go through many different courses and many different area of expertise. And the subjects that you study throughout your degree can be categorized into three different categories: your core fundamental courses, your technical courses, and finally your non-technical courses. So for this video, we are going to look at some of the core introductory courses that you need to become a chemical engineer. So do remember to watch the video till the very end, and if you do like it, then do remember to like, share, and subscribe to Chemical Engineering Life for more videos. Thank you. The very first subject is chemistry. As you may or may not know, chemistry is the study of chemicals, reactions, and chemical properties. Within chemical engineering, you will have to study the chemistry sub-subjects including organic, inorganic, bio, and physical chemistry. And apart from having theoretical classes on these topics, you will also be expected to work in laboratory where you look more at chemical synthesis, analytical chemistry, and learning the business of laboratory methodology. Now, all of these courses will most probably be already covered in your first year of study with both theoretical and the practicals, and the levels of these courses may differ from university to university, but generally you can expect a semi-advanced level of understanding and learning within these areas. You will still not be at the same level as someone pursuing a core chemistry degree, but you will still be able to understand what they do and be able to work with them in many areas. So you will still not be able to call yourself a chemist once you have taken these courses. Because as you know, the main job of a chemical engineer is to scale up chemical recipes, and therefore these courses make up the basics of chemical engineering. Because without knowing the fundamentals in chemistry, you will not be able to scale up the chemistry recipes into pilot scale experiments and then into larger scale production. At the same time, your knowledge in chemistry is what actually makes you stand out from the other engineers. Because as you will see that you will share the same technical knowledge with many of the other engineering branches, but as a chemical engineer, you will be the only one with the core, robust understanding in chemistry. Another subject that you will expect to study in chemical engineering is physics. It is a very general and a very broad subject in all the universities, and normally will be taught as one big course in your first year, and not even specifically for chemical engineers, and you can expect to share the course and the classroom with many of the other engineering students, for example from mechanical, electrical, civil, etc. Engineering is basically practical physics, right? So therefore, in a course like this, you will be exposed to everything. You will study everything from mechanics, thermodynamics, fluid mechanics, relative motion, electricity, magnetism, planetary motion, and even quantum mechanics. Not everything that you study in physics is relevant to chemical engineering, but still you will be expected to have at least a very fundamental understanding of how physics work and how they're relevant to the engineering branch. But still, some of the core topics of physics, such as fluid mechanics, thermodynamics, heat transfer, quantum mechanics, are very relevant for chemical engineers, and you can expect to have more advanced courses later in your degree where you will specifically focus on those chapters. Mathematics is the language of engineering, so therefore it is a no-brainer that mathematics will make up the majority of your engineering curriculum. The types of mathematics that you see in your engineering curriculum is a branch of applied mathematics, unlike pure mathematics. And the subtopics that you will have to learn in mathematics classes, that will include calculus, complex numbers, linear algebra, statistics, probability, and modeling. And these topics are the bare minimum in chemical engineering, and therefore, depending on the university or the type of specialization that you want to do, you can expect to have even more courses and even more topics that you will have to excel in mathematics. Now, the very first subtopic of physics that you can expect to study in your core basic courses is heat transfer. Now, heat transfer is the study of the transfer of heat within the systems. For example, have you ever wondered that if you leave a cup of coffee on the table and you leave it for 5 minutes, it gets cold, right? After taking a course in heat transfer, you will know exactly why it happens. And not only will you find out why it happens, but you will also be able to describe it using mathematical models and be able to investigate the effect of different variables. In your first year, it will most probably be a very simple basic introduction to what it is, and you can expect to have a more advanced courses throughout your degree. As a chemical engineer, you have to remember that heat is energy, and therefore, in order for you to be able to optimize and control the efficiency of your engineering systems, you will need to be very good in this subject, because this will make up the backbone of many of the technical courses that you will have to study in chemical engineering. Just like heat transfer, fluid mechanics is another branch of physics that you will have to study as a standalone subject, and it focuses on the mechanics of fluids and the forces on them. Just as the definition is very simple, the area of study is actually very difficult, and many times it is considered to be one of the most difficult basic courses within a chemical engineering degree because of the very high level of mathematics that is required. But regardless, you will have to master it to the highest level, because as a chemical engineer, every problem that you will face in your technical courses, in your projects, and later in your career, you will be working with fluids of some sort. And therefore, hence, without knowing the basics of fluid mechanics, it will become very difficult for you to solve those problems. Now, the subtopics of fluid mechanics can be divided up into fluid kinematics, where you study the methods of describing the motion of fluids, fluid dynamics, where you look at how forces affect the kinematics of fluids, or you could be studying fluid statistics, where you will be looking at what happens when you have a fluid that is at rest and how the force is affected in that way. At the same time, fluid mechanics is a very broad area, and you can go in depth in many of the directions that you want to, and depending on the university, you could take even further advanced courses in fluid mechanics. Finally, one of the most important things for a chemical engineering student is to learn how to use softwares and programs, because unlike high school, the level of mathematics and the problems that you'll be seeing in university you will not be able to solve them using a normal scientific calculator. So therefore, you will need to be able to learn how softwares work. You will be able to learn how you can use programming for your own benefit. And one of the most mandatory programming languages or softwares that are taught in universities around the globe include Excel, MATLAB, and Maple. Excel can normally be used for simple data analysis, simple calculations. MATLAB is primarily used to solve differential equations, to investigate different differential equations, and Maple is also used for solving mathematical equations and algebraic manipulation and for graphing purposes. In many universities, you may not find standalone courses focusing solely on these softwares, but they will probably be the sub-objective of many of the other courses that you will take. For example, if you take mathematics, they will teach you how to use Maple as a sub-objective. If you are in your heat transfer or your fluid dynamics class, they will teach you how to use MATLAB or Maple in order to solve the differential equations that you're seeing. But hands down, one of the most key skills and one of the most important area of study that you need to master in chemical engineering is actually the engineering softwares and the programming languages. And that is all for this video. But if you feel that we missed a subject, then do remember to tell us in the comments below, and also stay tuned for more videos. Look more at other basic courses and the technical courses and the non-technical courses in chemical engineering. And do remember to subscribe so you get notified when the video comes out. But thank you so much for watching, and if you have not done so already, become a free member today at ChemEnggLife and join the growing community of chemical engineers. But like I said, do not forget to like, share, and subscribe to ChemEnggLife channel for more videos. Thank you and have a great day.